Most failures in business don't start as big problems. They start small and get missed. By the time they show up, the damage is already done. The question is, are your systems actually holding up under pressure, or have they never really been tested? Let's start it up. Hello and welcome to Stack and Startup. Today I'm joined by Priyanshu Banerjee, a material scientist at Anderson Materials Evaluation. His work focuses on failure analysis, figuring out why materials and systems break, and translating that into actionable insight, which, when you step back, is not just an engineering problem, it's a decision making problem. Priyanshu, welcome to the show.
Hi, Jason. Thanks for inviting me and looking forward to the conversation.
Absolutely. And thank you for being here. You are now my second guest for
Mm.
an interview. So this is definitely momentous for, I think, everyone around.
Definitely, yeah, definitely.
So just give us like a brief background on you.
Yeah, sure. So I'm a material scientist slash project manager at Anderson Materials Evaluation. So we are a small business based out of Columbia, Maryland. Uh, what we do on a daily basis is basically figure out or work with materials on a daily basis, trying to solve material related issues. We talk to a lot of clients in regards to their issues that they are facing with their products, or any sort of material related failures, um, or issues that they come up on a daily basis, and try to solve them using our expertise and material characterization instruments or techniques that we have at place. So yeah.
Awesome, awesome. And that actually gets into probably the biggest question that I don't know if you've really had to sit down and think about, but if you can give us like something that's clear and concise, what does failure actually look like in your world?
uh, Failure.
Yeah, not an easy one, huh? I'm
Yeah.
going right into it.
Yeah, so it can look like it can vary, honestly. So let's say you're drinking coffee in the morning, right? And you pour your hot coffee in your mug, and it just breaks, and you don't know what caused it to break. So you bring your coffee mug in our lab, and we'll try to find out you know what happened to the coffee mug one bright morning. And we'll try to do a lot of analysis to see and try to find out the root cause of the problem, and help you uh, figure out what caused it, and if if uh, if there's a way you can solve it. So, and now you just take this coffee mug problem on a larger scale. So let's say we deal with a lot of companies on a day-to-day basis, where they have a lot of adhesive uh, you know uh, problems. Let's say there's this company that makes stickers uh, for variety of products, and their glue is not sticking to their surface. So what we do is we take a closer look at what's causing this problem. So if there's any surface contamination issues, or if there's anything that has been wrong with the epoxy or the adhesive itself, we try to put it under the microscope, see what's causing it, see try to trace the origin of the problem and solve it. That's pretty much it. Then we also work with a lot of construction materials, and bridges or real estate. Those kind of companies, they send us products on a daily basis, like what's causing this metal steel bar to fail. So we test them using various mechanical testing approaches that we have, and try to find out what's causing the metal or their product to fail on a daily basis. That's pretty much it.
Okay. Yeah,
Yeah.
because just because something breaks in a lab, that might actually be a good indication, like, it's actually supposed to do that, right?
Yeah, yeah, it is supposed to do that. Like recently, I'll give you an example. So there was this particular client that that came up with a bunch of concrete cylinders. So they were making bridge. So that they, I think it was the construction industry. I cannot name the client obviously, but it
Obviously,
was a
yeah.
construction company that made buildings and those kind of residential place, high rise towers and those kind of stuff. And they found that they had a crack in one of their towers. So they took a chunk out of concrete cylinder and brought it to us, and to determine what's causing the cylinder to crack, or the uh, structure to crack. So we did a bunch of analysis and found out that the ratio of the concrete that they used was not at par as to what was required. And that means that they now have to rework on their structure and make it again. So a lot of the times it's mostly it's little things. Actually, sometimes they don't use the right mix for certain products that's supposed to be mixed in a certain way. Sometimes they'll add something that is not needed there. Sometimes they'll not add something that is needed in the mix. So we just try to help that out. A lot of the times it's human error on their part, and a lot of the times it's just that the uh, material itself was not compatible to begin with.
Gotcha. And it's interesting that you mentioned bridges because both of us here are in Maryland, and a couple of years ago we had a very famous incident,
Yeah.
which unfortunately put Baltimore on the map, and not in a good way.
Not in a good way.
Has has have people come up to you and asked you like your take on that? And obviously I don't want you to necessarily go into a massive analysis of what happened and all that, but like, has anyone gotten like your take on it?
Honestly, no, no, I don't think so. It was pretty shattering to me. I remember I was with my friends at the gym in the morning, and it was playing over on the television, and everyone was collectively watching it, and while it was happening, and it was just sad. But
Yeah.
yeah, I mean, at
Sad, but I mean, the fact that the deaths, as tragic as they were kept so minimal is truly amazing.
yeah, yeah. I was surprised to see that the damage was kept to such a minimal extent. Like, obviously there were lives lost, but it
Yeah.
could have been worse. It could have been much worse than that. But honestly, in that case, it was something where the structure itself was not, was was fine. It was something where it was damaged due to it being collided with 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 a ship in that case. But yeah, most of the times what we deal with is where the client does not know as to why their product is failing in the first place, not because of an external
Right.
um, external reason. It's mostly sometimes where they have no clue as to uh, why it's failing. Yeah.
External where the ship hits, but
Yeah.
also where there just wasn't the safety precautions
Exactly. Yeah.
in the
Yeah.
original
In
design.
the original design, yes.
Yeah, that's
uh,
I
yes, a lot of I actually remember, I can give you an example where uh, we had a we had a client come in, and uh, they they and I should not be laughing at this, but so this was a person who went to a Chinese restaurant, right? And he
Okay.
ordered food, and they ordered food, and they broke a tooth while eating the food, right? So they got the piece of tooth, and and also the stuff that they ate, and they were trying to find out what could have happened, why they have a broken tooth. And we found out that there was the food that they ate. It was just organic. It was obviously food, but they had a broken, um, their tooth was already cracking, and they ate a frozen broccoli which did not cook well. so
Okay.
they uh, so they ended up breaking their tooth. So it was something which the client could have known, maybe taken precaution, as in, get go to a dentist more often, either rather than blaming the
So what I'm hearing here, and you say you shouldn't be laughing, but no, this sounds hilarious to
I
me.
know, I know, I know.
You did a material analysis on a human being. Is that what I'm hearing?
I know, yeah, you can say that, yeah, yeah, yeah. A lot of the times, yeah, we get
That
cases like these.
that's that's going to be turned into a short. I'm going to I'm already calling that right here.
Yeah. No, that yeah. Eh, I, I
Wow.
hope I hope the person does not, watch this, but it is what it is.
I mean, you did you said no names, but I mean
Yeah,
that is just an amazing story that
I know. Yeah,
you did a material analysis on people, and I'm not 100% sure how to feel about that, but it still does sound pretty funny.
that's funny. A lot of the times we get calls, and they always think that we are a pathology lab. So they'll call us and say, "Oh, you do testing, right? I want to send you a urine sample," and I'm like, "Oh no, we don't."
Not that, not that.
We're not that kind of a lab, but yeah, I
Right.
mean, if there's anything else, we can definitely help you
Oh
out.
man, that is almost too much, and a lot of real world examples of yeah, that's fantastic. Um, so what do you
Yeah.
think would be some of the costs of misdiagnosing within materials analysis?
Oh, uh, oh,
And not necessarily on your end, obviously, but like let's say a client brings you material for a bridge, and they're like, "Hey, we want to use this mixture of concrete
yeah.
because it's more cost effective," and it is misdiagnosing that material. I mean, obviously there could be failure, but how? What could be the cost of that?
Oh, I mean, till date we haven't had, some we haven't had issues where it costed, like, it costed the client really, where they had to pay a really hefty price for the whole thing, in terms of both monetarily, or or any other sense. But most of the times, the samples or the products that we test, they are mostly on their, testing phase. The client send us products while they send before they send it to the market as a commercial product. So it we actually work closely while they are developing their product. So it's
Okay.
not that it and I mean, in some cases, obviously, like the one that I just told you, where they sent us a concrete chunk after the building was ready and people were living in it. But it is not something that is dangerous in that sense, that can cause a real life disaster. But uh, as far as I know, most of the clients, they are well ahead, and they know well ahead what kind of problems they will be facing.
Okay.
So they are aware of that, and we help us out in a way where they know what the final product should look like. whereas we test them and tell them, okay, so this, you cannot use this particular material for your product, or you should not, or you should be rather using this one instead of the other one. So that's something how we deal with them. Like I'll tell you one example. So there was this company that made what's it called, cheese packaging bowls. So you know how these if you go to a supermarket, they have these cheese, frozen cheese inside plastic bowls, right, plastic cups. So they found out that some of their cups were shrinking while storing the cheese. So they were not able to figure out why it was doing that. Obviously they had to, once they seal the cheese and close the cups, or seal the lids, they vacuum it so that it doesn't get in contact with the surrounding air. So but the moment it hits the supermarket, these cheese cups will just collapse internally. So they sent us the uh, pro- product before this, the sent us these cups before they actually sent it to the market to find out what's causing the problem. So we diagnosed it. We figured out that it was a wrong material that they were using as compared to what they were using earlier for their other products. And we told them that it's not the same material that you were getting from your manufacturer. And that's it, that we were able to help them solve the problem.
That actually reminds me of like a Mythbusters episode where they imploded a container, like one of those oil
Yeah.
containers, and it because everything's like looks fine, looks fine, looks fine. Boom, done. It,
Yes,
is
exactly.
that what the
That's,
cheese did?
yeah, that's what it was happening. So they had these plastic cups, and they just shrunk. They just shrunk when they sealed it. And they could not figure out what was causing that. And eventually we realized that they had this particular additive in their plastic material that
Okay,
was not supposed to be there, which was causing it to behave like that. So yeah, but
yeah,
it took us a while to get to the root of the problem, because from the looks of it, all thermoplastics look the same. You cannot differentiate between one plastic from the other, so you had to do some analysis in regards to that.
yeah. I mean, we see the whole issue of plastics when it comes to recycling. You know, you get that
Yeah.
little recycling symbol with the number,
Yeah.
and you could look at 1,000 different plastic things. They have three different numbers on them, and you're like, wait,
Yes.
these are all different.
Different, yeah, exactly. They one little a little, like 1% of a different additive, and you change the whole composition of the plastic, and the whole purpose is different of using the material. So it's those minute details that we have to keep our eyes on, open to. Yeah.
Okay, awesome, awesome, awesome. So let's talk about some of the systems behind your accurate analysis. Uh, what systems ensures like accurate diagnostics?
Like in our lab we use a lot of we have uh, element elemental characterization systems where it can detect the elements that are present in a material,
Okay.
be it organic or inorganic. So we have FTIR, which is Fourier transform infrared spectroscopy. We have XRF. There's something that we call which detects mostly inorganic materials like metals and other inorganics. FTIR is used for always carbon-based materials, so hydrocarbons. It will detect most of the hydrocarbons. So the tooth that we analyzed was detected using FTIR. And uh, all these construction industries materials that we samples that we get, which has a lot of titanium, silicon, those kind of things. We use XRF or XRD. There's another uh, um, you know instrument that we have called X-ray diffraction, X-ray diffraction technique. We use that to detect the phases of these various cementitious materials that are present in those uh, in those concrete structures. We also have an a 3D electron microscope that is state of the art, where we try to look at the, obviously it does take cool pictures and everything, but we it can also detect what is present at the surface of your sample up to 6 microns. So it can detect the elements present on your sample, on the surface of your sample, up to 6 microns deep. Then there's another instrument that we have, which is called X-ray photoelectron spectroscopy, that can do the same thing. It won't take pictures, but it will tell you what is present on your surface up to a micron. So it's much more sensitive than the 3D electron microscope that we have. In addition to that, we have a mechanical testing instron, like universal testing machine, that can do tensile testing, you know, shear, bending, compression, all those kind of techniques, all those kind of tests on materials. And we also have a dedicated thermal analysis setup, where we can, where we have a bunch of instruments that can detect the glass transition temperature of a material, the crystal. It can tell you when a material changes its shape or form, from at what temperature, and it can also tell you at what temperature the material expands or contracts. So those kind of stuff.
Yeah, we when we had our pre-podcast interview, I did mention that I come from a calibration background,
Yeah,
and that was mostly dealing with RF, not so much with the mechanical side of
yeah,
things.
yeah.
A lot of RF, a lot of electrical, and we talked briefly on like the calibration, and how vital is that to your processes?
It is extremely vital. Like, I believe most of our clients, you know they require it. They also require us to, calibrate our systems and provide a calibration report as and when needed. So a lot of the times we have reference samples in place that we use to calibrate these instruments that we have in our lab. We also, like in case of my tensile testing setup that I use more often, we can only use those load cells to a certain limit, so that we don't damage the load cell or the instrument itself. So we make sure that we are not, putting in a lot of power or using it at a very high load uh, while performing tests. We also have dedicated reference samples that we match with the online database present. So let's say I'll have a 1018 steel bar that I'll test on my tensile testing setup, and based on the values that I get, I'll check with what the required or the certified results look like. And those things we do it on like on frequently and on a monthly basis, and try to, make sure that all our instruments are calibrated. As I said, we have reference samples with their with the required um, parameters present, that came with the instrument when we bought the instrument. So we make sure that we use those reference samples to make sure that the results that we are getting matches with what the manufacturer gave us. And most of the times we also cross examine these samples. So let's say I'm using one particular technique to get a result, I'll use the a different technique to make sure that I'm getting the same result for the sample. So that's also something that we do on a daily basis.
Awesome. Yeah, I mean, being able to reference back in the calibration world. That's called referencing it back to an artifact,
Yes,
something that is, a very known standard,
yes.
and that gives you the trust that you can then give to the customer, right?
Exactly. Like for XRF, we have nine different materials. I think we have sodium, silicon. Like these are artifacts that came from the manufacturer with their designated, parameters and plots. So we do test or analyze these artifacts every few weeks, just to make sure that whatever we are doing is what is matching the results that the artifacts came with. So that way we make sure that the results stay consistent throughout the period of time.
Okay.
Yeah.
And what would you say is one of the biggest misconceptions that people have of what you do? I mean,
um
other than testing urine, apparently.
no, yeah. uh a lot of the times people so there was I'll give you an incident. So there was this particular client who came up with uh, a stone, right? And they had a stone that they said that they got from a different country while they were, you know, on a trip to that country. And they were pretty confident that it was a gemstone, right? And they said that, oh, we went to these labs, and I'm pretty sure that it is a gemstone and it's worth a lot of money. But when I did X-ray diffraction on it, it turned out that it is like a regular rock, and you'll find it anywhere. It just looks like that. It can, so a lot of the times these clients will be disheartened, thinking that they spent a lot of money on proving that it is a gemstone, but it turns out that it's just a piece of rock that they found on the road or something like that. So those a lot of the times I'll get calls and people will come up with these big stones. They said that, oh, I found this under a lake, and I'm pretty sure it's a meteorite. and and we spend and then and I actually have stopped, taking those kind of projects now, because most 90, I would say 100% of the time, it's not a meteorite. And at the end of the day, they end up spending a lot of money just to prove that it's just a piece of rock. So those are some things that I deal with. I mean, a lot of the times the clients make up their mind thinking that, okay, this is the problem, this is what's causing it. But it turns out that there's something else behind it. So which is also the reason they need us. And I hope, and I hope if I can explain it to them in any other way, but uh, they they would say that, okay, I don't think this is the correct approach to test this. I don't think they would still not be happy with our test, and they'll go to a different lab, and then do the same thing again and spend money on it, which
Well, okay, so that's kind of interesting because I mean, you are a scientist, and
yeah.
because of that, I assume you are very well versed in the scientific method. It is the fact that they are then willing to necessarily falsify your readings. Isn't that also utilizing the scientific method right there?
I would say so. I mean, a lot of the times we say that, based on the study that we did, based on the analysis that we did, we don't think that it is the same thing that you're expecting it to be. But we might be wrong. You can just try a different technique and see. Maybe go to a different lab and maybe this needs more, detailed investigation, and some other people can help you with that. Some other lab can help you with that. But yeah, I mean, there's always that room of uh, uh, error in because we don't have all the analysis techniques that are present out there, and some of these samples, they require specialized analysis just to prove, that it is something. But we do let our clients know that, so they know it beforehand. But
Right.
it always is disheartening when, when they come up with a certain expectation and they want us to prove that it is the same thing. They want us to prove their expectation right, which I think is not the right way to look at it.
The whole expectation
Yeah.
versus the reality of the
Yeah.
situation.
Yeah.
I mean, I can definitely see, you know, way back during the gold rush days. Obviously, there were these miners digging up iron pyrite and swearing all up and down it was gold,
Yeah.
and they expected that they were going to get rich with
Yes.
these giant lumps, and it just that never panned out, and
That
why we
never
got a
planned.
lot of ghost towns out west.
Exactly. Exactly. That's true. But yeah, but most of these bigger clients, that they are making a commercialized product, they have a more streamlined approach as to, how what their product should look like at the end of, before it hits the market. So they have a clear idea as to what they want from a certain analysis, so that's
Okay.
always helpful. I mean, it's always better if the client has a more better knowledge as to what they are expecting from our analysis and our help in their issues. So it does our it makes our job easier, basically.
Okay.
Yeah.
Do you think that little disconnect, is it really just a lack of knowledge, or is it a lack of discipline where they're not accepting the results?
I would say it is a lack of knowledge most of the times, because uh, obviously you're not expected. I wouldn't know the same things that a finance guy would know, right? They That's the reason we are here, to help them out, to provide them with what science is telling us. So it's most of the times it's lack of knowledge. But s- uh, sometimes, in I've seen certain cases where I've helped the clients figure out the solution, and they end up making a similar, mistake, and coming back to us, which I think could be due to lack of discipline. But yeah.
Yeah, many years ago, I had a couple of trees taken down on my property,
Uh-huh.
and on my front door, there's a doormat that says there's no place like 127.0.0.1. And in the IT world, that is localhost, or colloquially known as home.
Okay.
And he saw that, and he didn't necessarily recognize the significance of it, other
Exactly.
than it looked like a computer thing, which that was correct. And he made an assumption that I was smart.
Okay.
And he said so. And I turned to him and I'm like, "Look, do I know a lot about computers? Absolutely. But you're a business owner. I don't do that. At least I didn't do that at the time.
Yeah.
So you've got your intelligence in that field. So
Exactly.
saying that I'm smart, don't just assume because I have a knowledge over here
Yeah.
that I'm necessarily smarter than you."
Exactly. No. Yeah. Uh, I mean, I have dealt with clients, and a lot of the times, they uh, a lot of the times this has also happened where they end up being right as well. And they like there was this there was this project that I worked on a while ago, and I think it was some sort of a like sand, some sort of a sand sample that the guy had. And he was, he was a geologist or something like that, so he had a better idea about it. And he was pretty adamant that the sand that he found had a certain trace amount of what's it called, titanium in it, right?
Okay.
And we did the analysis, and we could not find anything, any titanium from one of the analysis that we did. And but he sent us a different batch again, and he said that no, it has titanium in it, I know it. And this time around we tried a different technique, and we did end up finding that there was some trace amounts of titanium. And we realized that the approach that we were using to detect titanium in the material was incorrect. And uh, we were able to, obviously we didn't thankfully we were able to help him out, but it ended up that he was right to begin with, so he just wanted the confirmation from our end. So yeah, I mean, it always it always helps when when you work on these kind of projects, and you realize that there's a lot of things that you do not, yeah, that you do not know, and you still got to learn.
So, have you seen a lot of confirmation bias on either end of those interactions?
No, a lot of the times people are like, I don't know what's going on, so I just want to know why why this problem is happening, why my product is failing. So a lot of the times the client clearly have no idea, and they would just want our help in figuring out their uh, figuring out the solution. But most of the times we also work with uh, s- clients where they just want to get something, where they just want to know the properties of their product. They just want to know that how conductive their product is, how their material is. Let's say they make a composite material of with metal and polymer in it. They just want to know, I just want to test the properties of this material, be it electrical properties, thermal properties. So we do that kind of testing as analysis as well, where we just use an electrical conductivity analysis technique to report these values to the client, so that they can report it to their final data sheet or whatever they have for the before they hit the market. So those kind of things as well, where we just provide the data to them, just so that it is ju- just so that they know what the sample properties are.
Yeah, absolutely. And the electroconductivity and thermal conductivity is very important to my field in
Exactly.
computers and computing, and we're seeing that a lot in the development of AI. We're learning that it's so very difficult to cool these systems,
Yeah.
and so you're building. Obviously there's a lot of copper that's used for the electricity, but we're also seeing that in the thermal conductivity. Um, are there any materials that you've looked at that would necessarily help in that space to be even more efficient at removing heat, getting electricity where it needs to be, things of that
um,
nature?
I mean, not while working here, but I used to. So my background is while I was doing my PhD, right? I worked on certain semiconductor materials, where uh, we developed we developed a back then it was not a prototype, but we developed composite devices using semiconductor materials that could use body heat to generate electricity. A lot of the times, the materials that are used commercially, they are extremely toxic, and not sustainable enough, and terrible for the environment. So we used a mix of non-toxic materials that are present, that are also not rare, not rare earth, which are easily available. So we use those kind of materials to develop a device use uh, that can use the heat to convert into electricity. So yeah, I worked with some of those semiconductor materials back in the day um, that can that are good conductors of both electrical and thermal conductivity. And I hope in the future it turns out it uh, that it is commercialized to an extent where it is used on a daily basis. But we are too far away from that at this point.
So your watch on your wrist would be powered by you. So pro, you don't need batteries anymore. Con, you'll die in a week. Is that
Exactly. Exactly. Yeah. But the biggest disadvantage of the materials that I used, and I think I used a bunch of earlier when I started my research, it was bismuth, antimony, tellurium. Those were the standard semiconductor materials. But obviously, these are all toxic and rare earths. So then I moved to tetrahedrites, which is a copper based semiconductor material with a lot of different things in it. I think it has zinc. Um, it is a copper based mineral that is available with on a large on a, that is available commercially as well, but you can also mine it and then process it to make tetrahedrites. So we use tetrahedrites which are non-toxic and also sustainable, and then use those to generate these devices. So I believe that if but the biggest issue with these is basically they're not as efficient enough. So you basically need a like a meter long device just to generate enough electricity to light up an LED, you know. So
right?
we just wanted to get into that level where we don't need a ton of material just to uh, charge your battery or something like that. I hope in the future, I'm pretty sure a lot of these groups are still working on it, and eventually we'll get to that point where you can just use your body heat to generate electricity.
I'm just also imagining like, and I'm pretty sure that this would be absolutely impossible. But like, you get in your car and somehow your body heat is the is the
Yeah.
battery.
No,
Like,
yeah, I mean, I the theories are wild. I used to think that there would be a day when I'll just when we'll have trousers, I can just slide my phone in, and by the by the time I get to work, it's fully charged. So you can integrate these devices into textiles and stuff as well. So
right.
I think there are some I think they have used it in the military now, where they've integrated these thermoelectric materials or semiconductor materials uh, for military uniforms, where when you are at very cold temperatures it will keep you warm, because it will use your body heat and basically heat up the whole uniform. Or when you are at extreme hot temperatures it will keep you cool. So there actually is a prototype out there that they are using in the military.
And we've seen a lot of flexible materials. The space program was huge on this. The reason why we have a lot of ribbon cables in computers and in phones and a lot of, is the fact that they needed these flexible materials to be not necessarily woven in, but to augment the sensors in their spacesuits.
Yeah. Yep, exactly.
This is
uh
just like an evolution of that.
True, true, true. I mean, that's one of the attributes of the device that I worked on, that it was flexible enough. Earlier versions of this same materials were so rigid that that you can only use it as you can only use on surfaces that were flat.
Right.
So you can either attach it to your HVAC system, and so it will use the temperature difference from the HVAC and the ambient surroundings, and then generate electricity. But then we were able to get to the point where you can just bend it, fold it, and that's the reason we decided to use it for wearables.
Right. And again, we see that in the tech world. Samsung is famous for their folding phone.
Exactly.
In front of me, I have a monitor, a LCD monitor that has a slight curve to it, and even that was revolutionary
Yeah,
when they first came out. I was like,
that was
how can you do that?
true. I recently saw, I think it was Lenovo that had the rollable display where
Yeah,
you where your phone expanded and contracted. But I just didn't know that you could do that. I've seen foldable phones, but nothing rollable. And I was
I saw it at CES. I didn't go. Obviously, I saw it online, but CES they had a rollable TV. So like
Yeah.
imagine you had this like box up in the ceiling and
Exactly.
your TV just kind of like rolls down.
Yeah,
How,
yeah.
how cool is that?
That's pretty cool. That's like a projector screen. You just
But it's LCD, so it's not even
it's an
so you don't
LCD.
get
Yeah,
that loss of quality. You
exactly.
can use it in brighter environments than a projector. I mean,
Than a
the
projector. Exactly.
it truly is amazing. Some of the things, the new things that are coming out. I really wish battery technology would keep up with the rest of our technology.
Exactly.
That
Yeah. No. I mean, my lab, or my, no, not my current workplace, but where I did my PhD earlier, uh, the same lab, they are also working on flexible batteries.
okay.
It was not my project, but it's a separate project where they are working on flexible batteries, where they have moved on from, so there's already solid state batteries in the market, there's liquid batteries, the traditional conventional batteries, and now they have moved on to gel like electrolyte, right? So it is somewhere in between, a solid state battery and a liquid battery, and falls right in between, where the electrolyte is bendable and it's more gel like, so you can also fold it, and you can use it in a compact space as well. So yeah, that's pretty, I would say that's something new and I'm glad to be a part of that kind of a research. So I was excited to see that it's still not up to mark where it could give you, as much charge and discharge capabilities compared to, the other conventionally available lithium ion or solid state batteries. But we'll get there soon, I'm hoping.
I would be a little concerned with my clothes being batteries, especially if it was made by Samsung. I don't know if I'm ready to take that kind of risk.
Exactly. That's true. That's true. Yep.
So we talked a little bit about the technology, and let's talk about some of the technology and possibly automation that you do. What tools would save you the most time for your workflows?
uh I mean, obviously, uh honestly, the most amount of time that I spend working on any of the instrument that I have here, or the equipment that I have here, is the tensile testing machine. Honestly, it takes me a, it is restricted in the sense where I can only, uh, use a certain sample size for the, for the device. So it has to be either a dog bone, a structure, or like a rectangular structure. So in that case, I'll have to cut the samples and, you know um, or give it, or just do some sort of sample processing to it to get the required sample size that I need. So, and then there's another issue of setting up the sample in the tensile testing equipment, that is a bit of a hassle. So in that sense, I would have preferred something that can accommodate all shapes and sizes of samples for tests, whereas where I didn't have to put in so much work just to get the required sample size. So I would say if they can automate the tensile testing equipment that we have in our lab in a way that I would like it to, it would be helpful. But everything else, I think we just dump in the sample into the equipment and it just does its job. But tensile testing setup is has been traditionally been the same since the last 50 to 100 years, where you load a sample, you know, put the parameters, and it just does its thing. Uh, it I think it needs some revamp. That's
So the loading of samples, you think that that needs to be
yeah,
automated? Okay,
automated, yeah. Where, and I'm not sure, but there may be instruments right now in the market that can do that. It's just that I want it to accommodate all different shapes and sizes, rather
got
than
you.
just being sticking it to one certain uh, form factor, which I think is, yeah.
And what do you think that people are still doing manually? You mentioned having to cut up, but is there any other manual processes that you think shouldn't be manual? That should be standardized. That should be automated.
uh, that shouldn't be. Uh, like some of these uh, basics. Okay, so there were a lot of the times we get samples where we have to where it's a solid sample, right, and we have to uh, turn them into a powder like consistency. So what we traditionally use a mortar and pestle to crush them into a powder. So that's the one thing that comes to my mind right away, is if there's some way we can just put a sample into a machine and it just makes a powder out of it. I'm pretty sure there is one, but yeah, that's something that I would like to have in my lab. But yeah.
Just
Yeah,
has something that just grinds it all up, so you don't
grinds
have
it all
to.
up.
Yeah.
Yeah, yeah, yeah.
I
I'm
mean,
pretty
hey, you work on your arm strength that day.
exactly. Yeah, yeah.
It's not nothing.
It's not nothing, no. But some of these samples that we get, they are so stiff and so hard that there's no way a human can break it. Like I might break it into two pieces, but crushing it into a powder, that's another. Yeah, I don't think I can do it certain days. But I wish there was something where I can just turn it into a powder and using a machine. Yeah.
That kind of reminds me of a joke in the automotive world where it can't be tight if it's liquid.
Oh
Basically,
yeah,
basically,
exactly.
where they take a torch to a bolt in order to completely remove it. It's like,
Completely remove it. Yeah, yeah. Yeah, some of in fact, this is one of the cases where the client sent us a piece of bulk solid rock and wanted to see what's inside the rock. So I had to break the rock, and you know I don't think I have the human strength to break apart a rock and crush it. But yeah, we somehow managed. It took the four of us, but we managed.
uh, and that kind of reminds me of those YouTube channels where they have a hydraulic piston just crushing it, and it's like, why are we crushing this? Who cares? You're going to see
Yeah,
something blow up.
exactly. Yeah, yeah.
so,
Uh,
so how fun is that when you do get to destroy something?
oh, it's fun. It's so fun. I just do it. Sometimes um, I just do it for the fun of it. I mean, we have samples lying around in the lab all the time, and we want to see how what's the load capacity, or how what's the strength of this material, and we'll throw it under the compression setup, and it will just break it. The only reason we do not use it for other samples is we just don't know how the machine is going to react, and
Right.
that's the reason we try to use our hands and physically crush it. But sometimes we also don't want it to. Sometimes it also you have a sample, and when you just crush it, it just flattens, which does not dissolve anything, and we want to crush it into a fine powder, right? So that's
Right.
something we also want. Yeah.
And that brings me to kind of an impromptu question, but I think it's quite important. How much do you agree with Adam Savage when he says the difference between science and messing around is writing something down?
Uh, I kind of agree, honestly. I mean, a lot of the times, I think when we have messed around in the lab with all these fancy instruments that we have, we just didn't write it down, and I still think that the results that we ended up getting was something so out of the box that we did not see it coming. Like, I believe I was working on a sponge like material, and I didn't know what was the composition of the material or what it was made of, but it was definitely a sponge like material. And then the client wanted to do compression testing on the sample, right? So we put it on the under the testing machine, and it started compressing. And I was expecting that it will, go back to its original shape because it's a sponge, but it did not. And I was like, what's happening? Why? And then I left the sample for like, and then I sent him the report. I sent the client the report that it did not go back to its original shape. But then I think after a couple of weeks, I found out that it's slowly, you know, gaining it's slowly expanding and
Okay.
getting to its original shape. So yeah, that's what I said. A lot of the time, the client doesn't know what's gonna happen to the product, so they have a certain thing in mind that, okay, when you're gonna crush or press it, it will immediately expand, or something will happen like that, but it doesn't always work like that. So then I reached out to him again and said that, okay, so this is what I'm seeing in your sample right now, and that's what's happening. And the next time he sent us the same samples, and we then did a like timed analysis where tested the sample in like 7 days, 14 days, 28 days, to see how much of its shape it was able to recover.
Okay. Yeah,
So
it's
yeah,
recovery time.
yeah. So
Awesome.
so it also brings us to uh, it also helps that we end up doing something in mind and then realize that this is not the correct way to get the results, and then we do a completely new set of experiments with the sample, with the product. Yeah.
Okay. Awesome. Well, Priyanshu, I really appreciate you coming up and breaking all of this down, because this I do think that this goes just beyond the materials. Like the materials, obviously very important, uh,
Exactly.
but to just know, I think definitely is very very important, and it's good to know about how teams think, how they test,
Yeah.
and how they make decisions under pressure, to give a good pun.
Yeah. Yeah. Yeah.
And I do think that these patterns do show up in business as well. So again, I just want to really thank you for your time. And do you have any words of wisdom?
um I uh, I don't know. I mean, the only thing that I would like to say is, uh, you never know what uh, you never know about you never you're never certain about something unless you test and find out about it. So you can there's always something out there that will surprise you no matter what.
I think that is pretty much important
Yeah.
in life and everywhere else. So
Yep.
I definitely, uh, like I said, I definitely want to thank you for your insights on all this, and I want to thank my audience for tuning in to Stack and Startup. If you enjoyed this conversation, make sure to like and subscribe so you don't miss future episodes. You can find us on YouTube and everywhere you get your podcast to follow along as we continue to explore business and technology. Lastly, if you want to support these conversations directly, you can become a patron at patreon.com/stack and startup. So thank you again, and we will see you next time.
See you.